how to use the FluidSIM software demo version to simulate hydraulic circuits and pneumatic circuits. But in this video, I'll demonstrate how to simulate the hydraulic circuit as a part of assignments of 4 weeks internship program on automation. Let us open the software first. So after installation of the software, which I discussed in the last video, so there will be icon in this desktop. So double click on the icon and go to run. Remember, only 30 minutes it will work. Again, you have to start the application from the beginning if you want to continue it. Run. So go to the option called new. So this is the working area. So maximize the screen. Okay. So here different technology is there. Pneumatics is there, hydraulic is there, electrical concept is there according to IEC standard, electrical as per NEMA standard. Then electrical engineering, or that is electronics is there, miscellaneous is there, digital technology is there, graphite is there. Okay, so but our focus is on hydraulics technology in this video. So there is a plus mark on the hydraulics library. Just click on the plus mark. Okay, so here various sections you can find actuators, you can find cylinders and motors here. Then supply elements, you can find it here, hydraulic power source, for example hydraulic power tank, power pack, or pump, motor, all this connections you can find it here. Then measuring instruments like pressure gauge, differential pressure gauge, different types of measuring instruments. Okay. Then pressure to electrical signals also, that is pressure switch, you can get it here. Proportional hydraulics, you can get it here. Then direction control valves, 4x2, 4x3, and different spool configurations, you can find it here. Then mechanically operated or electrically operated or pilot operated, you can find it here. Then flow control valve, simple throttle valve, throttle check valve, different orifice control, and pressure control valve, you can find it here. And mobile hydraulics also, you can find it here. Okay, so our topic is only on industrial hydraulics. So here according to the exercise 1 in assignment number 1, this is assignment number 1. Okay, so you will have around 11 exercises in assignment number 1. So we will take one by one. So first I'll demonstrate the first one. So here hydraulic circuit is given and electrical circuit is given. This you already executed this project in the lab, using physical hydraulic trainer kits, right? You already got the output. But using simulation software, how to practice this circuits, both hydraulic and electrical, so that finally you will get a simulation by using electrical switches and relays, how to control the hydraulic movements. That is what we are discussing now. So every exercise will have one hydraulic circuit and electrical circuit, and whatever the output you got it in the lab, same output you should get it in the software also, so thereby completing that exercise. Okay, so let us start with the hydraulic circuit. This is the hydraulic circuit. Here the different types of components are there in this hydraulic circuit. First of all, P denotes that it's a pump line. It is not shown here. Pump, motor, tank, oil, it's not shown here, but you have to assume that P means it is a power pump line. Okay, it's a pressurized line. T means tank line. Okay, oil, after using of the oil, pressurized oil, finally it will go to the tank again through the tank ports, the tank line. Okay, so here 4x2 valve is there. DW3E is a 4x2 valve, single solenoid spring return valve. and df2.x is a throttle plus check valve, that is throttle check valve. It is used to control only one direction of cylinder. Okay, if there is no throttle, if there is no check valve, then we can control two direction, both forward as well as backward movement of cylinder can be controlled. But if since there is a check valve, only one direction can be controlled. And dd1.x is a pressure relief valve, and dz1.x is a pressure gauge. Okay. Uh, there is a single rod cylinder is a double acting single rod cylinder is there, and this is the actuator. So this is a hydraulic circuit. So first I'm going to draw hydraulic circuit here. So in the actuator section you can find it double acting cylinder. This is a double acting cylinder, but I wanted an rod should be in the left hand side. So right click, there is a mirror horizontal option is there, so I want it in the left side. And next is you can find direction control valve. Direction control valve we wanted in it is solenoid operated we want, so we go to the section for solenoid operated, and the first valve is 4x2 direction control valve. Okay, so this is here. Okay, we have taken 4x2 direction control valve, solenoid operated, and then throttle check valve is required. So that is available in flow control valves. Throttle check valve is available. So what is required? Then you can take up here in the supply elements. You can take up a fixed displacement pump, and there must be a tank. And to have the protection, see there is a protection in the circuit. If pressure in the cylinder exceeds the set value in the pressure relief valve, then pressure relief valve should open it. Okay, so that means if pressure in the system is more than the required, then pressure relief valve should open and allow the flow to the tank, thereby releasing the pressure in the system. So this is called the protection circuit. So here they have shown two pump line as per the physical hardware. In physical hardware there are only two pump lines are there and two tank lines are there. Okay, but in the software we can create a number of P points and T points. There is no limitation. So what I'll do is I'll go to the pressure control valves. In pressure control valve there is a first one is pressure relief valve is there. So this one I'll make it, and P, what I'll do is I'll connect it to pump line. And there is another tank is required. It's not two tanks actually, single tank, but we can use multiple times the symbol. Okay, this is the thing. And there is a measuring instruments. In that measuring instrument there is a pressure gauge is there, so you can have one pressure gauge here. Okay, see here, this is very simple. There is a pump line is connected to P of pressure relief valve, and T of pressure relief valve connected to tank line. In the same way, P line is connected to another P line is connected to the 4x2 direction control valve, and another tank line is connected to T of 4x2 direction control valve. Okay, so that let me complete that. So I want one more tank line, direction control valve tank line. So now if you observe here, A is connected to the rod chamber of the cylinder, and B is connected to piston chamber of the cylinder via throttle check valve. So I am connecting that. A is connected to the rod chamber, B is connected to throttle check valve, and throttle check valve is connected to piston chamber of the cylinder. This completes the hydraulic circuit. Okay, so let me continue. complete the electrical circuit. So in the electrical circuit, or we can also call it as relay circuit, so operating voltage of the solenoid even in the lab is it's 24 volts DC. Okay, I am calling this solenoid as, so double click on the solenoid, there is a small circle there, so double click on it and type Y1, that is the name of the solenoid. So you can give any name as per your wish. So I have just named the solenoid name, that is Y1. Now you have to take the IEC standard, electrical controls IEC standard, their power supply. So since operating voltage of solenoid is 24 volt DC, so we have to take 24 volts DC supply, and look at the diagram here. There is one normally open switch is there, that is called S1, and it is connected to a relay box called K1. So relay box will have a coil, relay coil, and then contact. So coil and contacts together form a relay unit. Okay, and so we are controlling solenoid Y1 with the help of switch through the relay. So that is why we call it as a relay circuit. Okay, so let me complete this. So let us take one normally open switch. So switches are available in here, switches, manual operated switches. So push button, normally open, and that is normally open. So double click on the switch, and in the label, in the description, you can have it like S1, and click on the display so that it will be displayed. See, S1 is a switch, name of the switch S1, and in the relay, there is a relay coil is there, this one. So even A2 is there. So this is a coil, and A1 is connected to a switch. A1 is connected to switch. See here, A1 of coil is connected to a switch, and A2 is connected to 0 volts, and another switch terminal is connected to 24 volts. So there is no continuity in this line. So when you operate switch S1, then pops the continuity, and then K1 can be on. So I have to name this coil as a K1. So double click, and identification here you can write K1. Okay, and then enter. So this line is done, and now you go to the manually operated switch. The downside general switches is there. Here normally open contact is a contact. There's a difference between switch and a contact, right? So this is a contact. Drag and drop here, and this one connected here. Okay, and here in the relays, in the relay section there is a solenoid. First one is a solenoid. So drag and drop the solenoid. And this one, double click on it. In the identification you have to type the name of the solenoid is Y1. Okay, so here also should be same name, here also should be same name, so that both will be linked. And this one should be labeled as K1, because contact belong to which relay, that is K1 relay. Double click on it, and then you have to link it to K1. Okay, so this is the electrical circuit. So you can use the text here. Let me see where it is. You can use the text to comment on that. The miscellaneous, let me find that. Okay, there's a text section. Go to the draw and text. And type here, there is a relay circuit. And you can go to draw text, that is hydraulic circuit. Okay, so now see, this is a limitation. This is a demo software, right? There's a limitation. So for example, you are doing the long, very big circuit, so it takes more time. In that case, what you can do it is, you just press Ctrl A and then Ctrl C. Just copy this, whatever completed the circuit, just copy this, so that once if software terminates after 30 minutes, you can open the software again using the command that Ctrl V. You can whatever amount of completion of circuit is there, you can continue from that point. Okay, that I'll show you in the next step. So let me go to the simulation. There is a play button option as a start. Just go to that. Okay, so now see, there is no electrical continuity here. The line number 1, line number 2 also there is no electrical continuity. So if you press S1 switch, current flows to K1. When K1 is on, the contacts belong to K1, which if it is closed, that will become open. If it is open, it becomes closed when coil is on. Since we are using normally open contact, when coil is on, contact become close. Observe this, so that solenoid is on when switch is operated. This is controlling cylinder using push button. Now the next section is how to document this exercise in the as an assignment. You should submit assignment, right? So how to document this? It's simple. So just copy the hydraulic circuit, okay, and then open the Word file. The Word file, just you have to mention it as project 1 and title is there given in the assignment. So just that is the title, and then go to the software and copy the hydraulic circuit. Try to give it in one sheet. One exercise should be presented in one sheet. So do the formatting, like center, and then go to the software again, copy the relay circuit, and then paste it. So this completes the exercise 1 in assignment number 1. So like that, you have to submit the 11 exercises in assignment number 1, and that completes the assignment number 1. Okay, so now I'll show you how to continue after even 30 minutes also. Means just Control A, Control C, and then close the software. Okay, again open the software here, double click, run, and go to new file option and then paste it, Control V, or right click, paste. See, that software that circuit can be retained here, and this circuit you can have a simulation. That is how we can work in the software more than 30 minutes. So I hope I've explained the hydraulic circuit and a relay circuit or electrical circuit. So if you have any questions, put it in the comment section. I can help you. Thank you everyone. If you like this video, please subscribe the channel. Thank you.